Okay, so hello everyone again. Today the presenter Dunja and me, we are presenting from home for two reasons. The first one is quite obvious to everyone here, and the second one is that we actually don't have our official service building anymore. It is not usable due to the earthquake that hit Zagreb on the 22nd of March this year. The earthquake was quite hard, and as you can see from some of the images taken from inside by our colleagues, there was many damage to it, and unfortunately it is not anymore usable for working inside. So from the next month we will be moving slowly, I hope, to a new building and a new location in the city. But let's look forward to a brighter future. Let's start the weather briefing with a standard question. Please, actually standard task for you, please take the markers and mark where are you listening from. Of course, if you are listening from somewhere outside of Europe, please write it down on the left side of the slide. You can write either your city or the country you're listening from. I'll give a couple of seconds, maybe 10-20 seconds to do this, so we can continue onward. I can see there's a lot of people from mostly Central Europe, yeah, but some, of course, from the British Isles, from UK, actually, from Spain, Lithuania. I can see somebody from Pretoria, but he didn't write it down, but nevertheless, very nice. Oh, somebody from Argentina as well. Good, good, great. Thank you all for marking this up. Okay, so let's start with a simple image of the 10.8 micrometer channel and the sign-up observations overlaid over the image. From this morning at 6 UTC, we can see that the temperatures this morning ranged from around -1, -2 degrees in Russia and in northern Scandinavia, and down to around 11, 14, even 20 degrees on the Mediterranean. So what more about this image? You see the biggest systems over the continent. To the west we have a big cyclone, and again, and also, I'm sorry, to the east we also have one cyclone over Russia. In the middle and the central parts of Europe we have some kind of a low pressure system or something similar. We will see it a bit later, with lower cloudiness, some high cloudiness here in southern Germany, and low cloudiness all around the north, from Iceland to the Scandinavian countries of Norway and Sweden. Let's continue. One short task for you. Draw the borders between the air masses. One hint, just follow basically the jet streams and try to contour where are the borders of the air masses. And I will give you something like 20 seconds for that, maybe a bit more. And while you are drawing the borders of the air masses, also mark the centers of PV anomalies. You have a couple of bigger centers of PV anomalies, a couple of maybe smaller, but the bigger ones are more important. Okay, yeah, I see in general a good idea, yeah, of the jet streams and everything. Yes, good. Okay, I see you didn't actually mark the PV anomalies a lot. Oh yeah, there are some markings of that in here. Okay, good. Thanks. Let's just continue shortly forward. Just yet to tell something about the Fortuity centers. So, as you probably know already, you can see them also by going to the e-port and just clicking on PV anomalies. You can see them also in this water vapor 6.2 channel by these dark areas, quite distinctive. So you have a couple of them here, another big PV anomaly here over Russia and over Latvia. Some of the smaller ones are also visible, especially in the previous image, something like here. You can see them in the fields of the ECMWF model as well here on this slide, but they do not affect the weather that much. Also, this one here as well, northwest, of Ireland and Scotland is present, but there's no front associated with it or any bigger weather events going on. Okay. Anyway, task from before, where I asked you to draw the borders between the air masses. So with this air mass RGB, you could have a bit clearer image of where the air masses are. So approximately, I can draw something like this. Maybe this is a good approximation of the border between the air masses. So we have colder here, warmer here. And yes, as you see, people are also drawing down here in the Mediterranean region. We have here the subtropical jet, and the border between the air masses is basically the polar jet. Okay, I can continue forward. In this image, again, you can see maybe a bit more details of that. The jet streams here around the cyclone, and here in Russia, the subtropical jet over the Mediterranean and northern Africa. Of course, there is also this one here, but this is just an individual jet up there because there is basically nothing but a high pressure system here over Iceland, so the gradient got a bit closer in on 300 HPA, so the wind got a bit higher. Anyway, the borders between the air masses are also nicely seen with these theta E temperatures. You can see it. You can see them very well here in this model map, and distinguish them quite well. Just shortly then about the systems and the pressure areas. So we have two big lows over the continent, one over Russia and one actually over the Atlantic this morning, but this one probably also already got more to the east over the UK and more into France. And as we can see, it's over the sea with these dense pressure gradients. It was quite windy, and of course around this one in Russia we will see a bit later the wind over the areas. There is also a low over here in the northern Atlantic Ocean, but it doesn't have any associated fronts with it, only just some cloudiness in front of it. And because of the PV anomaly, small PV anomaly although, but it caused enough perturbation for these clouds to rise ahead of it. The winds here, okay, yeah, I forgot the lows here in the central part. So there are two lows in the central part of Europe, and they will cause some changing weather, especially in the Balkans part and this southeastern part of Europe. Especially this low in combination with this cold front, which will move then to the east and southeast, will then bring some very changing weather, and has already brought changing weather to these parts of Balkans and southeastern Europe. We've just now had some short showers and maybe somewhere even a lightning or something, but I didn't check it. Regarding the wind is currently blowing from the southwest and locally, possibly, especially on the Adriatic, from southeast, because of the obvious gradients that are pointing in that direction. After the passage of, I'm sorry, I'll just clear the annotations. After the passage of this low and the fronts, the wind will shortly change to the northwest, but then as this cyclone is approaching in with its strong gradients, the wind will already shift to southwest again during today evening and already tomorrow. And then again on Friday we will have some changing weather, and actually in the days ahead, because of there's no real high pressure system over the central parts of Europe, but rather these cyclones and low pressure area around. But after that, at the end of the week, and possibly and especially at the beginning of the next, for now the models are showing that there is a possibility that a rather strong ridge and actually high pressure system will arrive. So we are hoping, actually I'm hoping, that the nice weather will continue from the beginning of the next week. Some just shortly about the winds, as I've shown you already. Around the cyclones there are the gradients of the pressure are quite high, especially here over the sea, where the friction is low, the winds are high. That also confirms the Anak Sea measurement. As you can see here, the winds are very strong. I don't know actually what are the speeds of this red color. I'm sorry for that. But as you can see from the model data, the speeds are going up to 20 meters per second, so quite high speeds. And of course here over Russia, of course here the friction is between the air and the ground is higher, so the speeds are not that high as here over the sea. But again, speeds up to 15 meters per second are not to be neglected. And yes, as in the last month, since the last weather briefing, there have been so many actually phenomena and events that happened. We will not be able to go through all of them and analyze them. I have just picked up some of them that were very interesting for me during the last month. Some of them you all have analyzed on the on our Facebook page, on the EUMeTrain Facebook page, and on Twitter. But what I want to say now is that today Dunja and me will just analyze this one, the front passing through Croatia, the Croatia and Bosnia and Herzegovina fires, the Karakum dust at the end of March, and very shortly Anak Krakatau eruption on the 10th. So I will now give the presenter rights to Dunja so she can continue with her part, and then I will finish at the end.
Hello, yes, thank you very much. Now I will share my desktop, just a moment. This is my presentation, yes. Well, good afternoon once again from Zagreb, and there are some thunder around already. My name is Dunja Plačko-Vršnak, and I'm working as a forecaster at the Meteorological and Hydrological Service of Croatia. Marko already mentioned, but I will repeat it, that I'm working from home not only because of corona pandemic situation, but also because approximately 1 month ago in Zagreb, and our building was badly damaged. This is, for example, the operational room. And now we are homeless, unfortunately. Well, after nice introduction from Marko, I will continue with analysis of several synoptic situations that occur during the April. I would like to say that this April in Croatia was not typical spring month, especially related to precipitation. Here we can see temperature and precipitation anomalies from 1981-2010 climate, and the positive anomalies of temperature can be noticed. These red numbers. But for precipitation, there is a serious lack of precipitation. Even we can talk about the draft condition in Croatia. And for example, the last month with precipitation normal or greater than normal was recorded in December last year. Let's go back to the temperature. Here you can see deviation of temperature for Zagreb for April till 28. Zagreb is the capital of Croatia, and it is situated in the continental part of Croatia. And I will say a few words about the situation in the beginning and in the middle of the month. Why? Well, first, at the beginning of the month, we had a frost in the inland of Croatia due to stable weather situation and cold air in the upper part of the atmosphere above Croatia. And even on the 2nd of April, there was an absolute minimum temperature measured at some station in the continental part of Croatia. Of course, absolute minimum temperature for April. In this satellite image, we can see nice cyclonic activity from Atlantic Ocean through Mediterranean Sea and part to the east. Besides, we can distinguish warm from cold air also. Well, now I will have one question for you. Could you show me on this image where is a polar front and where is the subtropical front is? I will give you just a few seconds because
yeah, some people are annotating.
Yeah, because I allow them, but they are going one by one. And
yeah, I'm sorry for that. Then it's not working, but yeah.
Okay. Okay, but okay, this is really not it's easy question for you. Sorry to have this problem. And now I will, sorry for that, I will just skip that, and of course we can, yeah, sorry. Okay. Let's see, the isota has 300 hectopascals, which indicate the position of the jet. And in this case, the position of the pole front and the position of the subtropical front, it is nicely can be nicely seen with this isota from ECMW model. Then quick look at the situation at 500 hectopascals shows here you can see existence of upper level lows, which is connecting with cyclonic activity south of Croatia, and also we can see the ridge of the Atlantic Ocean. One upper level low is also situated west of the Scandinavia. And from northwest, we had a cold advection over the part of Central Europe and over Croatia. The mean sea level pressure also confirmed the situation described before. We can notice 4 centers of cyclones from Atlantic to the East Mediterranean and far to the east. And also deep cyclone is situated above the Norwegian Sea. The second situation, synoptic situation, which was interesting during the April in Croatia, is the period from 6 till 10 of April, when over Croatia was no clouds at all. I mean, in 5 days in a row, we have bright sky without any clouds above our heads, and it was really not so common. Well, on this EUMet RGB, we can see dry air over central part of the Europe. High pressure dominated over Central Europe with moist air around the high, and we can notice the cyclonic activity, especially over Atlantic. Of course, the red sign here is the sign. The red color is the sign of the dry air with missing moisture. And let's look at the situation in the middle of that period. It was the 8th of April at 12 UTC. We can see some frontal zones and still a very, very big and high, big high pressure system. Now, here you can see just from the surface weather chart where the frontal zones are. Again, we can easily recognize the position of the jet with on this air mass image here with isota at 300 hectopascals. Even better, we can see the relation of the high pressure field on this natural color RGB. And now I also have one question for you. We will try to do that again. Well, please could you show me where are the water clouds on this image are? Maybe now I will have better. Yeah. Okay. Yes. Thank you. Again, I have a problem with this allowing you to annotate, and now I will stop annotating. And yes, you were more or less okay. You have a lot of you have a right, correct answer. This whitish color on this image is an indicator of water cloud, but this RGB is not always suitable for distinguish water clouds from mixed or ice clouds. For example, we can look at the cloud phase RGB, but unfortunately I don't have it here. Of course, in this image, we can nicely notice the snow cover over the Alps, and also we can notice the few sand dots over the mountainous part of Balkan Peninsula. And also we can see a sharp contrast between vegetation and desert is, for example, visible over North Africa. The green color is area with vegetation, and the desert are in the brownish color. And when the vegetation color is affected along the draft period, the green area in this RGB transformed to brownish tones. And as we can see, our Croatia and neighboring country, there are some brownish color on this RGB. Okay. Again, there's something. My presentation is stopped. Yeah. Here is the natural color RGB overlaid with the 500 hectopascals isobars, and we can see the strong reach over the Central Europe and the upper level low over the eastern part of the Mediterranean. At the end of that cloudless period, the ridge has weakened and the flow from northwest was stronger. We can see a small cumulus cloud with the Croatia on this high resolution visible RGB image, and also we can see the smoke of the forest fires on the mountainous part of Croatia. This is on mountain sea light. This is the end. It is near the border with Bosnia and Herzegovina. Now I will show you a loop of image from 8 UTC till 45 every 15 minutes. The image is every 15 minutes, and you can see appearance of a cumulus cloud over the continental part of Croatia, but also a smoke from forest fire on sea light here. Yeah, and here's a nice, very nice image from the Terra satellite. This is true color RGB at approximately 10:05. Also, you can notice the smoke from forest fires, not only in Croatia, but also in Bosnia and Herzegovina. And the last part of presentation will be connected with the quick passage of the cold front over Croatia. Croatia is here, and this is the front. And This front brought some rain, finally, some rain in Croatia and Dalmatia, for example, up to 30 millimeters, brought stormy Bora wind along the coast with speed up to 150 kilometers per hour, and brought some snow, not only in a mountainous part of Croatia. Again, I will show you the look from 0014 of April till 0015 of April, and now you can follow the frontal zone and the passage of the front. Well, let's start with some synoptic parameters. This is the geopotential height at 500 hectopascals, with nice, you can recognize which shows the trough connecting with the upper level low, which is situated over Finland. Now we will switch to visible channel 0.8, where we can see cloudiness in more detail. But unfortunately, we can hardly see the ISO lines. But now I zoom in. We can see the zone of high peak gradient. Oh, I don't know if you can hear this. It's really thunder in Zagreb. Okay. Well, we can nicely see the high gradient of thickness isolines which are overlaid on this satellite image. Let's go to the next image. We can see strong temperature advection at 700 hectopascals behind and over the cloud band, and very weak warm advection in front of it. The zero line of temperature advection is close to the leading edge of the frontal cloud band. Now we can imagine something like here. Yeah. The next image, we can see the isotoph on 300 hectopascals, and we can see the jet axis, which indicates the position. Yeah, here I can indicate the position of the jet axis, which is parallel to the frontal cloud band. I also made a few vertical sections. On the first, you can see the position of the front indicated by the equivalent potential temperature, and we have here the relative humidity. There is a high value of relative humidity in front of the frontal zone and below behind. I hope that you can see that. And the second cross-section is the convergence and divergence. We have convergence within the frontal zone, and you can see it here. The next one is the temperature advection, where we have a cold advection below the frontal zone and a warm advection above. And here's the temperature, where you can see the warm air in front of the frontal zone up to the 650 hectopascals, and the colder air, of course, behind the front. And in the end, we have upward motion, which is indicated with omega here, upward motion on the top of the frontal and convergence zone. And all of that was expected because we have a passage of the phone. But I would like to ask you, can you tell me about, after that short synoptic analyze, can you tell me, is that Anak Krakatau code songs? I will try once again to allow you to or put it in the maybe in the chat box, answer or somehow indicate it to me here on the image, which is Anak Krakatau. Yes. Now I will stop annotating and yes, it is Anak Krakatau. And if you want to refresh your knowledge, you can visit again EUMeTrain web page and find more about the Ana and Tata kind of things in Scotland. Well, thank you very much. This is all from my side. I will stop sharing my desktop and, well, Marko, you can proceed.
Okay, thank you, Dunja, for your presentation. I see we are already over time, so I will try to go as quickly as possible. So at the end of March, we had a dust outbreak, which brought quite a lot of dust over the area of Balkans and especially southeastern Europe. Here on this slide, you can see the natural color RGB overlaid with the mean sea level pressure field. To the north, there was a high pressure system. To the south, there was a low pressure system, and very dense gradients of pressure developed in the region, and that's why a very strong wind starts to blow also at the surface. Here you can see in the sign-up observations, the wind in the Aral Sea or Aral Lake Basin was blowing up to 20 meters per second, maybe even more, 25. And because of that, lots and lots of dust was lifted into the air and was then following the wind. Here you can already see in Russia how the sun observation was basically haze, and here dust storm. So if we now continue and if we follow the dust being advected from the Aral Sea basin, we can see very, very thick dust cloud from here in the dust RGB on March 24. And with the geopotential height at 850 HPA, we can see how the dust is trying to turn according to the geopotential height. And that was the case because of that, actually, and because of this merging of isolines, the dust got a path, basically, that led it something like this through Russia and Ukraine, all the way to Balkans, where we will end up in the end. We can see how these isolines merged, and then when the dust was already on the way, the high pressure system again developed, and in combination with this cyclone to the south, basically the wind sucked in all the dust that it had on its way and brought it to the southeastern Europe. Already on the 27th March, in one day, you can see how the clouds disappeared. Now, I don't say that's completely because of the dust, but dust for sure did have some part in that, especially in the parts farther away from the cyclone. And this is the 27th at 12 UTC, when the dust was basically at its highest level over the region. Just shortly to see how NASA's Terra satellite saw that as well. You can see the 24th March, around the RLC basin. The time is something like 7:41 UTC. And the next day, you can see a huge cloud of dust going over Russia and into already Black Sea and Ukraine. The dust cloud here. And on 27th, you can see the dust, the hazy areas here over the Balkans covered in dust. And basically the dust is still actually ongoing. You can see trails of it here all the way almost to its origin. Some impressions from that day. This image was taken, photo was taken from by our colleague Christina. The skies that day in the afternoon should have been almost clear or partly cloudy, as I remember. But as you can see, it's so dusty, so the sun is, well, barely visible. These are some numbers from our Hungarian colleagues that they issued a notice about this dust earlier that day on their website. And on the image below, you can see the quantities of, and actually the concentrations of the dust of the PM10 particles going all the way from the origin and through Ukraine, Black Sea, and to Croatia in the end. And the highest concentrations were around here, South Ukraine, with around 300 micrograms per cubic meter, which is basically 6 times more than normal values. And something very shortly about the eruption of Anak Krakatau volcano on 10th April. Unfortunately, the volcano erupted just before 15 UTC, which was already night there in Indonesia. So unfortunately, there are no visible imagery, no, for example, cloud phase RGB or something else. But in these 24-hour microphysics and air mass RGBs, you can very nicely see the SO2 cloud that was spewed out of the volcano. And for both of those, the reason you can see these colors very well in 24-hour microphysics is the 8.7 micrometer channel, because it is absorbed rather nicely by the SO2 particles in the air, and the air mass RGB, the 7.3 micrometer channel, is responsible for these nice colors, because again, it is nicely absorbed by the this part of the spectrum is nicely absorbed by the SO2 particles. That way the differences here and here are bigger and the colors stick out. Stick out, the green and the red one. So this is all from us now. Thanks for listening. The next weather briefing will be held by the German Weather Service, Deutsche Wetterdienst, in May, but we don't still know which date. And if you want, you can check the new cyclogenesis training module on our website, written by Andreas Wirt, that is also here. So again, thank you all for listening, and if you have any questions, please feel free to write in the chat box.